Hey, what's up, guys? Chung here. So today, I want to talk about another. Let's take a look at this LeetCode problem, uh, 134 gas station. And okay, let's take a look at this problem here. So you're given like n gas stations along a circular route, right? Where the amount of gas at station I is the gas I, and and another cost array where the cost of this I is the cost where you need to spend from the current station to the next station, and you need to return like the gas station, which gas station you that can be start, right? You can start the starting point of the gas station where you can travel like the whole circle. Let's say if you start from 3, you need to be able to travel to 4, 5, and then 1, 2, 3, and come back to 3 in the end, right? So travel, if you if you cannot travel the whole circle, no matter which gas station you started, you just need to return -1, right? So how should we think about this problem, you know? And I think there's like some tricky thought here. I'll try to explain it. So I think first we will need to know is that, okay, so the first concept is if the total gas, right, it's equal greater than the total cost, right? Total cost. Then we know there has to be a there has to be a station that will allow us to finish the whole trip, right? Basically to circle to travel to all the stations. All right, I think that's a fact we need to keep in mind. And with that in mind, and then the next thing is just a matter of how can we find that station, right? So what we will do? So basically uh we will have like basically we'll be loop through from the first station, and then we'll keep like a current gas and a current cost, right? So basically, uh, actually, we don't need to do this. Sorry, yeah. Uh, okay, I just remove everything, but okay. So we just need to keep like a tank, basically current tank, right? Current tank, and on each station, basically this thing will be keep adding the differences between the gas and the cost, right? Basically, that's the gas gas I minus cost cost I, right? So every time when we see a gas stations, we'll keep adding the differences, right, to the tank here. Basically, we're accumulating all the gases we have seen so far and all the costs we have seen so far, and we check if this tank is smaller than 0, right? So if it's smaller than 0, then it means, right, what does it mean? It means that we cannot go from the current station to the next station. right? Because we don't have enough tank. Then we just need to move the starting point, to our current I plus one, right? Because we know, and we will also need to clear this tank to to zero, right? Because that's like a basic start, right? So how basically we're starting making a new start. We will like discard what we have traveled before. So and in the end we just return this start. So why will this work, right? I mean, why would this work? Let's say we start from here and then we didn't we we didn't have code to make sure. Let's say we start from 4. How can we know it can go 5 and then coming back to 1, 2, 3, 4 and then 4, right? So here there's like a uh, let's say there's like a gas station here, gas station like there's one, 1, 2, 3, 4, 5, and 6. Uh, let's say we're at station 4 here, right? We're at station 4 and then we see, oh, the gas is not enough. The tank, the tank is not enough for us to move from 4 to 5, right? Then then what do we have? Then we know if there is a possible gas station that can allow us to travel everything uh, uh, to do a whole circle travel, it has to be something uh, right to the current to the current station. Why, right? How can we prove that? Because from previously 0 to here, right? We already accumulated all the gas we can collect and all the costs we can collect from the beginning to here, right? And so basically at any position here, right? So let's say for one, in two, or at three, right? Because let's say we accumulate everything uh, in this range, but when we start from here, but how about the starting point right in between, right? And because we already have the total gas, right? So we have the total gas smaller than the total cost, right? So we already have this fact until this 4. That's why we don't have enough gas to travel from 4 to 5, right? Let's say we can travel from 1 to 2, right? Let's assume we can travel from 1 to 2, and basically we're trying to see if this 2 is a valid starting point, right? Then the total gas minus a pre, right? So the pre is something like this, right? The pre-gas. Uh, will be minus, and then here there will be a total cost minus pre pre-cost, right? So let's assuming from 1 to 2 we can travel it, right? What does it mean? It means that the pre-gas, let's say the pre-gas and pre-cost stands for the travel, the gas and the cost we need from 1 to 2, right? Let's say if we can travel from 1 to 2, and then the pre-gas will be greater than the pre-cost, right? and and then the total gas minus pre-gas will be the rest will be the gas we have from 2 to 4, right? And same thing for the total cost minus pre-cost will be the total cost we have for the from 2 to 4, right? Since the total gas is always smaller than the total cost, right? And if the pre-gas is greater than pre-cost, then we have what? We know that the total gas will definitely be small. This formula, right? So the remaining, so the the gas from 2 to 4 will be definitely smaller than the cost from 2 to 4, right? Because this one is smaller than total gas smaller than cost, but here we're removing more, right, from the gas, and of course the result will be even smaller than this one. So we know even though we can travel from 1 to 2, but starting from any point between 1 and 4, right, there won't be any valid point for us to travel the whole process basically. So from 2 to 4, there won't be any enough gas, right? Same thing for 3, right? Let's say assuming we can travel from 1 to 3, right? But then from 3 onward to 4, any there won't be enough gas, right? So and then we know the only possible gas station will be on the right side. We just keep doing it until we just return the final start, and then we know our result because we also check if there is a valid, right? If there is a valid, we just use the start point. If not, we just simply return -1. Okay, so all right, so let's just do this, right? And we just do this, right? We just do a sum, right? We just do a quick sum. Sum gas, right, is greater or equal is smaller than the sum of costs, right? Then we do what? We simply return -1, right? That's how we check if there is a valid station, right? So if there is, right, what do? We do a tank. We can maintain a tank here, right? So we for and then we have starting point is I is 0 in this case. So because we start from 0 in range, right? In range length of gas, right? So we start from 0 and then we do what? We keep updating this tank, right? This gas, right? Gas of I minus the cost of I. And then if the tank is less than 0, right, then we know the the starting point has to be somewhere on the right side, right? And then we just remove we just clear the tank, just like as if we're starting as if we're starting from this starting point. Yeah, this is kind of like of a greedy concept here, but because every time, right, if as long as it's not enough, there's not enough gas, we are assuming, right? We're assuming okay, so we can the next one should be can be our starting point. Basically, we're being optimistic, right? Okay, so if this one we know, okay, so we know what station that which cannot be the starting point, then we just try the next available one, right? And we're assuming that one is our starting point, right? And then we just clear the tank. If this one is not, right, and then we just move this one forward again and again until we reach the end, right? And here it's safe for us to just return the start because that will be our starting point because we already check if there is a valid a gas station here, right? And then in the end, we can just simply return whatever left for us, right? Yeah, cool. I think yeah, that should do it. Yeah, I think there's some tricky thought here. Like once we have the starting point, right? How can we know it did the last starting point can give us the valid result, right? So we have because we have some like checks here, and like I said, we have some a simple proof that anything that left on the left side before the current I won't be a valid start point, and then we just remove all, all the impossible gas stations, and the last thing left will be our result, right? Okay, cool. I think that's it for this problem, and thank you so much for watching the video, and see you guys soon. Bye.